Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. And what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but they will apply a lot of the same principles apply over in the UK as well. Now, if you do have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring live chat. If you're watching this after the premiere, then just feel free to leave a comment underneath the video and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on's diagnostic technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had 30 different franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru. So I worked in a dealership, and over time, I guess, just became the default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bed. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is guided component testing. Simplify your diagnostics. Now, if you've used guided component tests, you may be aware of what I'm talking about. But if you have not used guided component testing and you have a tool that's capable of guided component testing, you'll see, hopefully by the end of this, that this will save you a ton of time when it comes to testing stuff. Because really, we have two different types of diagnostic tools, right? We have scanners and we have scopes. And when I think of a scanner, I like to think of it as a really nice compass. It's going to point us in the right direction. It's going to show us where we need to look, where we need to go, but it's only showing us the effect after it already happened. In order to find the cause of the problem, because every effect needs a cause and every cause has an effect, so scope is where that comes in. So I'm going to actually test the component or test the wiring, test something in order to tell where the actual problem lies and not just look at the symptom. So if we think about a vehicle's computer, let's think of it like a house. It's got a front door and it's got a back door. Now, coming in that front door is going to be all my raw data inputs. So my coolant temp sensor, oxygen sensor, NOx sensor, all of those things are going to come in. The computer is then going to process that information, however it's programmed to do that. And that's the key point right there. It's only as good as its programming. And that's why we have these things called reflashes, right? So it processes that information and then it spits that processed data out the back door to the scan tool. So if I'm only looking at that data using a scan tool, I'm only looking at it after the computer's got its hands all over it and, might not always necessarily be accurate. A good friend of mine used to say, scan tools don't lie, they get lied to, right? There's many different reasons we can have erroneous data in there. And top of mind comes with coding, right? That's why reflashing, or the code that's inside the computer. That's why we have reflashes. But we got to definitely check both sides and compare, because I might get a no answer out of my scanner, like no signal. And then if I come to look over here at the component, I actually do have the component working. So we need to be able to check both sides of the computer, both the front and the back. And really, when it comes down to it, the difference is in the details. So if we see this top part of the screen, that is scanner data coming out the back door, right? Process data coming out. And it's oxygen sensor volt. Now, if we look at the bottom here, that is a scope hooked up to the same oxygen sensor, reading the same voltage. But if you look at these two red boxes, that shows the same amount of time passed. And I don't know about you, but I think those two look pretty different. Those two little dropouts right there, if you were just looking at scanner data, you wouldn't be able to see those or even know that it was even a thing. Now, it's not really the scan tool's fault, it's more the car's fault, just because of how I mentioned how it processes data. So it's got to process it, send it to the tool, takes it in, processes it, send it out the tool, right? So it's got to go kind of back and forth. So this will be hooked up through the OBD2 port, and this will be connected directly to the oxygen sensor with the vehicle running, right? So you can see a lot more fine detail in those signals between that one and that one. It's like watching a 4K ultra high HD TV versus like one of those little maybe black and white things you had in the garage growing up, right? So when it comes to testing components, and that's what we're talking about, testing components with a scope or meter, and it's really going to fall into these three buckets, right? So we have opens, shorts, and resistance problem. So an open in the line, we could go two ways. We could go no voltage to the component. So if I'm trying to supply 5 volts and it's not making it there, then that's an open, perhaps. That's making no voltage go to the component. Or other side of that, maybe we have voltage going to the component, but we have no voltage coming back on the signal wire. So that could be an open situation coming back. Maybe the wire's cut, something. Next one is short. So a short could be too much voltage or not enough voltage. So excess voltage is short to power. Maybe I got a 5 volt and a 12 volt rubbing next to each other inside the harness there. And then all of a sudden they kind of short together. Maybe I get 7 volts, 10 volts going down a 5 volt line. That's not good. Or I have insufficient voltage, a short to ground. So if I'm rubbing on the back of a block or something like that, or a cylinder head, and it's pinching the harness, and then the harness is shorting out to ground, maybe it's pulling 4.5 volts out of that line. I only got half a volt, or maybe it's internally short where it's shorting the ground. And then we have resistance, right? So we have corrosion or damage. Corrosion, especially like up where I live, they put a bunch of crud on the road. And anything made of metal, copper included, is going to get that green fuzzy stuff all over it. Or damage. If I had a frayed wire, say it was a multi-strand wire, and I only have 1 or 2 strands left connecting, well, it's still going to flow. It's just not going to be able to flow enough current to maybe make it work. So damage can increase resistance going through it as well. So if we think about it, what is a lab scope anyways? If I just totally coming in off the street, not aware of what a scope is, how would I describe it? I like to think of it as a window. It's a little window I'm going to look through, and I'm going to see what is this signal that I'm measuring doing. Voltage, current, pressure, whatever I happen to be reading. It's a measurement on the vertical axis over a time period on the horizontal axis. So I need to know a few things. If I'm going to use a scope, I just kind of need to know a few things. Now, there's plenty of places you can learn it, and there's plenty of places I'm sure you could probably look it up. But let's see, what do I need to know? First, I need to know, where is this component I want to test? Where is it located on the vehicle? Good to know. How about, how does the component work? Is it a solenoid? Is it a switch? Is it a thermistor? What kind of part is it, and how does it work? Because if I need to know how, I need to know how it works in order to make sure it's working properly, right? Wiring pin out. Where does power go? Where does ground go? Where's the signal wire on this particular component? How am I testing it? Am I using a voltage test? Am I doing a current flow test? Am I doing a resistance test? Am I doing pressure test? By the way, if I were to test a fuel injector, I could test it any of these 4 ways. And we're going to talk a little bit more about that when we go live on the tool here in a minute. So that's just one component, and I can test it 4 different ways. And there's a multitude of components where you can test at least 3 of these 4. So just think about that. Take that into consideration. How am I going to test it? What am I testing for? What range do I need? Remember that vertical axis on the scope. Do I need 5 volts, 10 volts, 20 volts, 100 volts? What's the best tool for my signal? Maybe a scope isn't the right tool. Maybe I need a DVOM. Maybe the DVOM isn't right. Maybe I need a graphing DVOM. Maybe I need a scope. Maybe I need an ignition scope because I'm testing ignition components or drivability issues. And then, most importantly, I think, what is a good signal? What's it supposed to be? What's the voltage? Is it supposed to be 5 volts? Is it supposed to be 7 volts? What is it supposed to look like if I'm looking at it with a scope? All these things might not necessarily be published by the manufacturer, or they might not be easy enough to get to from the manufacturer. And then we have, this is how we used to look it up, right? We had binders full of diagrams and flow charts and all that stuff. Luckily now it's digital, but I remember seeing the shelves like this. It's a lot of information that I need to collect before I even think about using a scope. And this is how guided component test really helps. So how does it help me? Well, it gives me operations. It gives me location. It gives me connector views. It gives me tech notes. It gives me between 1 and 6 testing methods of a different way to test it. All that information, all in one place, all in one screen. Now that helps avoid unnecessary parts replacement, because hopefully I'll be testing the part and not replacing it unnecessarily, which in turn helps prevent comebacks or misdiagnosis. Also prevents loss of customer. If you think about what's worse than a comeback, it's a never comeback. They go somewhere else down the street and they fix it instead. Also, the other side of that coin, though, is could help attract new customers to your shop. You're the shop that gets it right the first time and tests everything properly. Maybe you become that shop and you get that good reputation. And then overall, doesn't matter where you work in a shop. If you're the secretary, you're the owner, or you're the lead tech or the oil change tech, helps shops profitability. Having a profitable shop is good for anybody involved. Also inside the guided component test, let alone the 7 million tests that go back to 1981. Yes, by the way, there's over 7 million guided component tests inside the tool that go back to 1981. But built-in training. This is just a small sample of the types of classes that are in there. 10-minute basic electronics class, advanced ignition system class, air conditioning. There's 65 different categories of class within the tool. And the beauty of it is I don't have to hook up to a car to see it. It's going to be right there, ready to go anytime I need it. So training at hand. Here's just one example with radar cruise control, right? So adaptive cruise control uses radar to monitor vehicles' position in traffic, et cetera, et cetera. It's going to walk you through how it works, kind of at a high level. It kind of depends on the component, but we can see how that works. Also inside, as I said, it's going to show you how to hook it up. So, how do I need to hook it up to the tool and how do I hook it up to the car? Where to hook it up? It's going to give me a connector view, and then it's going to give me my colors, right? If we have the wire colors, we'll have it, blue, yellow, etc. And then what it should look like. In this case, it's a signature test, so that's what it should look like. Otherwise, it could give us a voltage or a resistance value or something. It's going to give you what good is on the screen, right here on the screen, ready to go. Also newly added in the spring, and we're adding a ton more in the fall as well. In any of the tools that got a component test, you're going to see actual pictures for locations. Now, instead of it telling you in a paragraph, it's going to show you. So here's an overall view of roughly where it is, and then it gives you a direct arrow to show you exactly where it is. It's going to be on Windows-based tools and non-Windows-based tools, as long as it's got a component test. So there's a blown up version of that. You can see, all right, so it's over here. There's the hydraulic unit, and then there's the ABS control module that we're looking for right there in this particular. Also in guided component test, they've improved the way the connectors look. So you'll be seeing this as a running change, kind of as we do our updates, the more connectors they get through. We realized that, screen resolutions got bigger. Well, the connectors didn't necessarily scale up. So going from these small connectors that are kind of hard to see, going up to a much larger, easier to see connector. The connector didn't change. It's just the artwork changed with it, right? So it's got, connectors, pin 1's here, pin 3 is there, and you can imagine 2 would be in the middle, right? All right, so let's go live on the tool and we'll talk about, let's first start with what if I didn't have or didn't use guided component test, because you may have it and still never use it, right? So first thing I need to do is, I need to look up all this information, right? So I'll go into my repair information. Here I got a 2012 BMW, and let's just say on this 2012 BMW, I suspect that the injector is bad. Maybe it's a drivability problem somewhere. So I'm going to load in here, and we got to reload because we're loading from scratch here. Okay, N52 engine. Okay. All right, so this is shop key, and I'm going to look up injector. Now remember, this is information from BMW, so maybe a little different. TSBs for a fuel injector. This one doesn't necessarily apply, and then we have a fuel composition tester, so there's really not a lot there. All right. How about specifications? What have I got in? Let's see. It looks like I got torque specs, so I know how far to tighten it down, and I know what thread it is. Looks like that's about it. Looks like we don't have any resistance values or anything. How about OEM test procedure? Way to test it? No, idle speed control rationality diagnosis. So it's going to give you some parameters that it monitors in order to know whether or not it's running properly. All right. How about, well, we're going to skip guided component testing because, as I said, we're not using it right now. And then we'll see the difference, right? So that's that, and that's that. Those three things right there. Component operation. Well, how does this fuel injector operate? It's going to walk me through. Well, some more of that speed control stuff. All right, emissions reduction strategy monitoring. Different things like that. Ignition timing, so on. So still not a ton of information on that. How about wiring diagrams? That should be good. Yep. So on page 3, because that's where the injectors are. And we'll see, we need to highlight all the injectors because it only does one at a time first. All right. There. All right, good. Dim that out. So we can see they all share a common power. So it's this orange wire is power on all of them. Then they have individual control wires. So white, green, white, yellow, white, brown, white, violet, and white. So where do those go? I go over here, and we can go down a little bit. We can see it goes right to the PCM. So I got my injector signals right there. It's going to bring. It's going to tell me if I need to test it at PCM or not. All right, good. So at least I know the wiring diagram. At least I know what color wire I need to test if I'm going to test it voltage or resistance. Will just ohm it out across the two, right? Okay. So that's about as much information as I can get out of BMW in this case. Oh, yeah, remove and replace is going to tell me how to at least take it apart. It looks like it's fairly easy enough at the top. Kind of not easy to get to the connector to test it, but at least I can get it to take it out. That, and then parts. So I go into parts, looks like $208 for the fuel injector right there. Item number 2. So that would be item number 2 right here. So there's item number 2. So now I kind of know where it is. It's like on the top of the motor somewhere. I know roughly what wires I need to check. And let's go check it then, I guess. So then I need to know, well, what do I need to test? So I want to use my scope, but then first thing I want to do is ohm this thing out, and I can't, well, I'm in the lab scope and it doesn't let me do ohms. Maybe my digital multimeter, my friendly digital multimeter. Maybe that'll work. Oh, yeah, there we go. There's ohm. All right, cool. That says, though, I want to calibrate the probe. So, yeah, we'll calibrate the probe. And all we got to do that is it's going to tell me connect channel 3 and 4 together. So that's the red and the blue. We're going to plug them in, hit OK. And it's going to calibrate. And then it's going to open. All right, now it should be 0 ohms because they're connected directly to each other. There shouldn't be any resistance. But let's hook it up to my fuel injector. All right, so plug in one end there. And we'll plug in one end there and see what happens. All right, nothing. Oh, cycling down. All right, there we go. 11.24 ohms. Is that good? Oh, could be. Maybe it is. Maybe it isn't. I don't know. Wasn't able to find a spec. Now I could test it across other injectors, I suppose, and see what happens there. I don't know. What happens if I check voltage? Let's check voltage. So my multimeter, and we'll check voltage, and I'm seeing 15.24 volts. Is that good? Is that supply voltage? What's going on with it? That seems a little high if we're running an alternator, right? A little high for an alternator. I don't know what good is. I guess, if I'm checking power, maybe it'll be okay. Let's try, maybe I can try my graphing meter instead. We'll do that. We'll do that. Well, that doesn't look the same. It's kind of going off the screen too. It looks kind of weird. Just going up and down a lot. And that's way more than 15 volts too. So that's interesting. How about I use my scope? Go to my scope and do volts. Oh, there we go. That's what it looks like. Now, maybe in this case, I was set up like maybe that. Right? I have no idea. I can't really see what's going on. So then I got to mess around with the settings and see if I can make it work. Well, let's see. That's 2 seconds. Seems like it's too long. 100 milliseconds. I'm trying to get just one. Oh, there we go. It's just one on the screen there. And then for my scale, is it 5 volts? Well, definitely not. It's going off the screen there. So maybe let's try 20. Still can't really see it. Let's go up to 50. Hey, that's pretty close. I still can't see the top though. Still can't see the top. I don't know how far this goes. So let's go to 100. All right, there we go. Now I have a fuel injector pattern on the screen. Now I know from knowledge from doing this time and again that that's what it's kind of supposed to look like, right? Whether or not the voltage values are right, we can get a little further into that. But in this case, see how long that took me and see how little information I actually had to go on. And I could imagine if you're not using guided component tests, that's you're going to have to approach it, right? So before we use that, now let's do it the easy way. So I show you the hard way first. Let's do it the easy. Let's go to the guided component test. Once I load a car, it's going to list the different systems I can test stuff in. So if I want to test the injector, that's in the engine. And then we'll see components or maybe even subsystems in there. So in this case, fuel system is where the injector lives. And then we'll go to the injector. All right, first thing I want to know is tell me more about this injector. Component information. So it is a conventional fuel injector. These are normally closed solenoids responsible for delivering atomized fuel into the intake manifold. When energized, the coil winding inside the fuel injector will create an electromagnetic field. This will pull the pintle off the seat and allow the injector to spray fuel. Injector on time is known as pulse width and controlled by the ECM based on engine speed, load, and temperature. No. Says ignition positive is supplied to the injectors by the fuel injector relay, so we need to know where that is. And the PCM switch is the injector ground side. So that's why it shows us the ECM over here. Best test location is at the ECM, right rear of engine compartment under the white E-box cover. So it tells us where that is. And the fuel injectors themselves are mounted to the cylinder head just in front of the intake manifold in the fuel realm. We saw that picture when we looked in the service information. All right, good to know. Supply voltage to the injectors through this fuse to the main relay and then to the injectors. So I know the path through there. All right, so everything else here is going to be a test. And we can test it 4 different ways. We can do pulse width, resistance, signature, and current. So I'm going to go to resistance first because that's what I did first there. And it's going to tell me where to connect my leads. Good to know. Red to injector control signal and blue to fuse 5 with the fuse removed. Should be 10 to 14 ohms. At about 68 degrees, resistance should be about 12 ohms. It's a little warmer than 68 degrees in here. So due to an inaccessibility of individual injector connectors, test at the DME may be required. Key off, connected. Okay, hit V meter. I already calibrated it, so I don't need to do that. And boom, right there, right up to the 11.24 ohms that we knew. Should be 10 to 14 at about 68 degrees. It should be about 12, so that's pretty darn close. Looks like we're good there. All right. And it set it up for me. And it pulled up that it was a DVOM that I needed. Next one we'll do is a pulse width test. So I can go in here. It's going to tell me it should be about 2.5 to 3.5 milliseconds. I'll hit V meter. And then we'll see. We'll change the pulse width a little bit. Goes up, comes down, goes up, comes down. So if I were to rev the engine, we'd be able to see it go up and down. Now this is a graphing meter. So for the resistance test, it picked the DVOM. For this test, it takes a graphing meter. So already we didn't have to go back and forth and figure out what meter is appropriate. It's just there. And then when I go into signature test, it's going to tell me once again where to plug in, give me the connector view. May need to raise the voltage levels. That's good to know if the signal is clipped, and it gives me a known good pattern. I hit view meter. There's my pattern. Scroll up. There's my known good pattern. Looks pretty close. Now I can bring this down a little bit with my simulator. Probably something like that. And then I can move this over, move it around. I can still do that. Now, also note that it automatically set the voltage and it automatically set the time to where it needed to be. I didn't have to muss around with trying to figure out what those settings have to be. Now, it is a little off the screen, and it does say may need to raise the voltage. So if I just go down here, I can still do everything that I can do in the scope, I can do here. So let's change the scale up to 100. There we go. Now I can see the top and I know where that is. Now I can go in and measure it later using the cursors and so on. But having the tool be able to do all this for me and having everything on the screen. Once again, there's my known good. There's the pattern I get. That's pretty darn close considering it's a simulator. It's about as close as we're going to get. And on a normal car, that would be a normal signal for a fuel injector. So a wealth of information in here. I didn't have to go elsewhere to look it up. It's already installed in the tool. As long as you have a tool with guided component test in it, it will have this information in it. Depending on where your software level is, you may have more, you may have less, depending on what the software level is. If you got current software, you got the most you can have. Now, another thing I'd like to talk about. So that's the base information in there using that 2012. I'm going to back out of the car and then just go back in, and we can see the selection of vehicles. There's 42 different vehicles in here other than demonstration that we can go in and we can test stuff on. So let's say Cadillac, 1981, DeVille with a 4.1. Not a lot of stuff going on the vehicle to begin with, but if I go into the carburetor system, we can see 4, 8, 12, 13, 14, 15, 14, I guess, because we don't count abbreviations, but HEI pickup coil, NOx sensor, aero sensor, ECT, all this stuff's in there, readily available if I wanted to do something like this. Also note that I'd like to mention is at the very top, this has kind of moved around throughout the years, but now it's finally, we've settled on, it's going to be right at top, and we call it class. So this is those classes I was telling you about earlier in the PowerPoint. So we got power user tests with different current probe tests, dual channel tests, secondary ignition tests, and pressure transducer tests. So that'll be not VIN specific. It's going to be more of a generalized test, but yes, available in there. And we also have how-to. So how-to is where all the meat and potatoes is inside this. This is where all the classes are. So 65 different categories of class. If I scroll down, you can see things like data link connector. What is what pin on the data link connector? What should I see for a waveform on a K-line? What should I see a waveform on a CAN bus? You can see all that information right there. And then it's actually hit view meter. It's going to test it. It's going to set it up for you as well. Let's see, 10-minute electronics classes, current, diode continuity, scientific notation, voltage, Ohm's law. Maybe I forgot my Ohm's law today and I need a quick refresher course. It's going to be right in there. All sorts of information, 65 different categories. And the other beautiful thing about it is I don't have to be hooked up to a car to use this. It's already there. I can just go in with classes. I can go into any car. Any car that's in here, I can go in and I can load up. I don't know. Let's see. Let's go to like a GMC 19 Acadia. All right, with a 3.6. What do we have? ABS charging system, engine, and transmission. So I can go in and if I wanted to find out more about the map sensor. There it is. There's the signal wire. There's the pinouts on the computer, and then it's going to give me my known goods rate. Any vehicle you can just go in and look up. You don't have to be connected to a vehicle in order to utilize this information, which is helpful in many ways. I don't have to look up where to hook it up. I don't have to look up the wiring diagram. I don't have to look up how it works. I don't have to even know what good is because the tool will tell me what good is. This is a database culled over the last, what does it start? 96 with the Vantage, the original Vantage, the one that matched the red brick. Database has started since then, moving all the way up till about 2021, 2022. Depends on the year. Depends on how many people we have to build them, because like I said, these tests are built. So Chevy's up to 21, BMW's up to 20, Audi's up to 20, Kia's up to 21, right? So it just depends on the manufacturer. You're within a couple of years. Because the thing is, like I said, real live people hook up to these cars and do this. It's like their job. They go in, they plug in, they take pictures, they get all the connector views, they know what the goods are, and they write articles on. These are real live cars, so they have to actually be able to get to test the car. So that's why sometimes you're at least a couple years back, because A, it takes a little while to write them, and B, it takes a little while to find them. So definitely a untapped resource for a large number of people I know. If you do have a tool with the scope and the guided component test, hop in there and just check out what all you have in there. It's not just North America either. If you're in UK, you got UK cars. You're in Brazil, I think they got it down Brazil too. Australia, they got it. So for each individual market, whatever car you cover, we have guided component tests to cover a good amount of cars, no matter where you're at. So definitely a good way to simplify your diagnostics day. And with that, that is our time here today. So make sure you tune in for new diagnostic content every week. We will be premiering a new video every Wednesday at 7 p.m. UK time. So make sure you check it out on the YouTube channel. If you're watching, of course, you would be watching this on YouTube, but make sure you subscribe, thumbs up, ring the little notification bell so you know anytime we post new content. And it's youtube.com/SnapOnDiagnosticsUK. With that, time for questions. If you have any questions, just feel free. Once again, if you're watching this on a premiere, just leave it in the live chat and we'll answer those. Otherwise, leave a comment under the video and we will get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've given you today. Hopefully, we'll see you next week. Hopefully, you can watch and see you on any of our other videos. Have a good week. Have a good night and take care.